Welcome everyone to JADAK's Reagent Authentication with RFID webinar. My name is Justina Valencia and I'm part of the marketing group at JADAK North America. On the line we have our presenter Rob Geiger who will walk us through the presentation. At this time I'd like for everyone to please mute their lines to avoid any interruptions and encourage you to type in any questions you may have into the chat window directed to the host, which is me. This way I can read your questions aloud to Rob once he has finished his presentation. We will do our best to answer all of your questions. However, if time does not allow it, we will email you back the answers to your questions. Now, a little about our presenter, Rob. Rob is a senior systems engineer with over 30 years of experience in technology development and management. He has been with us at JADAK for over 10 years, working directly in the auto ID for medical industry, which includes barcode, machine vision, and RFID. His education includes a master's in science and physics and a bachelor's in science and physics and mathematics, so he really knows his stuff. His children, which are in the picture shown, are also pretty smart. Similar to their dad, they major in mechanical engineering and biology. So now I'd like to hand the mic off to the man of the hour, Rob. Rob, take it away.
All right. Thank you, Justina. Step one, I just wanted to make sure you can hear me, okay?
Yep, I can hear you.
Okay, very good. So what we're going to talk about today is reagent authentication with RFID. So just to kind of go over the agenda briefly, we're going to start off with a brief introduction to JADAK as a company and what we can provide, as well as some basics on RFID itself. Then we're going to go into why would you want to use RFID for reagent authentication. How does this RFID meet your needs in a clinical diagnostic application? Ultimately, what kind of problems are we going to be solving with RFID? And then to finish up the webinar, we'll go through a variety of case studies and examples that we've done here previously at JADAK to kind of give you a feel for how this is used in practice. And then we can take some questions. So just a little bit about JADAK itself. It's a business unit of Novanta, which is actually a holding company for a variety of companies that work in the medical sphere. JADAK as a company started in the year 2000 to provide auto ID solutions specifically for medical suppliers. You know, and with that in mind, we understand what a medical supplier is, what is important to a medical supplier. Lock configurations, we understand that change is bad, notifications as early as possible, and that's really where JADAK shines as a company. In 2014, JADAK was purchased by Novanta. As I had mentioned, they have several other medical component suppliers. JADAK is a leader in auto ID solutions for medical device manufacturers, including RFID, machine vision, barcoding, printing, which are chart recorders used in EKG machines and defibrillators, things like that, as well as color and light measurement. 90% of the customers that we deal with are in the medical and biopharmaceutical space, as well as point-of-care providers in the hospital environment. As I had mentioned before, because of this, we really understand what's important to manufacturers of medical devices. We provide locked configurations on every part we deliver. We can't necessarily get the FDA approval for you, but we do know what's important to our suppliers, or the people we supply components to. And because of that, we are an ISO 9001 and 13485 company. As I'd mentioned before, we're a barcoding company. We started off as a barcoding company. So why would you choose RFID over barcode? And it really gets down to using the right tool for the right application. There are uses where barcode is going to be a superior technology and places where RFID is going to shine over barcode. So some of the comparisons we do want to talk about between the two technologies is the read, write, and modify capability. Barcode can obviously read its data, but it does not have the capability to write data back to that tag and modify it. So if that's a need, you should definitely think about RFID. Line of sight, barcode is obviously an optical technology, so line of sight is going to be important. RFID, not so much. And because of this, you can actually take an RFID tag, bury it underneath a label that has human readable on it, for instance, or even for that matter, mold it right into the plastics of cartridges or devices. Can it be copied? RFID, no, and by that people might say, oh, you can clone it, but there are methods we can use, whether it's encryption, password protection, some other things where we can prevent those tags from being copied, and if they are copied, they're going to be useless to the person trying to copy it. Where barcode, by and large, is just basic information and can be copied. The reason there's an asterisk on there is we do work with folks that deal with controlled substances and things like that for identification using barcode. They can put a red filter overlay on top of that so that the barcode reader can actually see it and read it, but you can't throw it on a copy machine and copy it. Encryption capable? Sure, you can put encrypted data both into a barcode and to an RFID device. And then ultimately cost. How much does it cost to put this auto ID method onto consumables that you might be using? And the cost for a barcode obviously is just the amount of cost or the amount that it takes to print a label and stick it onto a device. So it's relatively minimal. Where RFID, just because of the technology involved, there is going to be an antenna, there's going to be a small IC with some memory on it. So there is, although the prices for tags are getting much lower over the years, there is still going to be a small but non-negligible cost associated with RFID technology. And that's kind of why we're doing this presentation, to kind of go over in what applications would you use it and why would you use it? Why would you throw those extra few cents onto your disposables? So reagent authentication must address anti-counterfeiting technology, obviously. So why do we want to use RFID? Really to protect your product and name and prevent counterfeiting. It needs to act fast and not interfere with what the user normally does. So anything that is associated with any technology that you put into a device for tracking in validity needs to be easy and not interfere with what a clinician would normally do. You should use proven standards that conform to common standards that are used worldwide. And by that, I mean stay away from proprietary technology. What this does is kind of paint you into a corner, and if the technology goes obsolete, you're kind of left holding the bag. So just make sure that you choose a technology that is used worldwide, and there are standards associated with it. Ideally, you want to use a technology that someone attempting to counterfeit it might not even know that it's there. Getting to the previous slide, where line of sight really isn't necessary with a barcode technology. There are some integration details that you do want to be aware of, and we'll talk about those a little bit later, but since it's not an optical technology, you don't have to worry about seeing the tag. And you want something that is easy to check and provides automatic authentication both during manufacture and clinical process. So these tags do have information about the component itself, how it's used perhaps, when it was manufactured, when it expires. Somebody's got to write that onto that tag, and you want to make sure that that's easy to do in a manufacturing environment. And then ultimately, after it's produced and used in the clinical device, you want to make sure it's quick and easy to use in that application as well. So just as a little bit of introduction about RFID technology, I'm not sure how many people are fully aware of what's involved and what kind of RFID is out there. So we're just going to go over the basics of the two technologies excuse me, we're going to talk about today. These are HF or high frequency and UHF or ultra high frequency. So for HF technology, it's, if you want to think about it, it's definitely more of a near field technology. And by this we mean it will read on the order of inches to millimeters. It operates at 13.56 megahertz, and this is true for both standard HF and NFC or near-field communication. And ultimately, it's a magnetic coupling process where you have fundamentally a loop antenna and a loop antenna on the tag as well. Because of this magnetic coupling, that's why you're pretty much limited to relatively short distances in this case. The other is UHF, or ultra-high frequency. So this is a longer range technology, but it definitely can be tuned to shorter ranges. This is typically used in warehousing and retail space, but it definitely has its applications in the medical space as well. It operates between 860 and 960 megahertz, does frequency hopping between particular bands for UHF. And this is all dictated by the FCC equivalents from the various countries. So in the U.S., I think the range is about 902 to 928 where it operates. And if you want to think about it from a technology standpoint, it's more of an E field, more like the rabbit ears on your old TV sets where the energy is distributed and picked up. And in all these cases, basically that energy coming from the interrogator, whether it's HF or UHF, the energy is distributed into space. It's picked up by either the antenna or the loop in the case of HF. It powers on the IC that happens to be on there, and that's where the communication starts. The other thing I wanted to talk just a little bit about for the UHF devices, I wanted to make sure everybody was aware that all of the UHF devices that JADAK provides are RAIN compliant. And you might wonder, what is RAIN? It's really just a wireless technology concept that connects items to the internet. So the interrogator would read the tag, and the RAIN application actually allows connection to the cloud for location authentication, just verifying where items are and what they're used for. And RAIN is actually a global alliance that promotes adoption of UHF technologies and is very similar to other alliances like the NFC Forum, Wi-Fi Alliance, Bluetooth SIG. It's really basically a standard for use of UHF RFID tags and its connection and communication to the cloud. So this slide shows some of the examples of the products that JADAK can provide. So in the first column here, you had the HF products. That's the M2 interrogator that I'm pointing to, which can do both a standard HF at 13.593 and the NFC standard, which is 14.443. The Gemini unit is specifically designed for NFC reading. And then the M1 Mini, this isn't actually to scale. The M1 Mini is one of the smallest interrogators that you can purchase. It's about the size of a quarter and was originally designed to go into a wristwatch. So that kind of gives you an indication of the size. On the UHF side, we have the fixed mount readers, the M6 fixed mount, and the Sargus, and this just provides a case and connections for both power, Ethernet if that's what you need, as well as antenna ports, and just gives you some options for the UHF readers. But ultimately, inside these devices are the embedded systems that are in the third column. The Nano, which I'm pointing to now, is a very small form factor. It is only slightly bigger than a quarter. This would have to be embedded onto your designs. It does have one antenna port, relatively low power but small size, so it fits a lot of our applications. The micros are a little bit bigger, a little bit more feature rich, has the capability for 2 antenna ports coming off of those. And then the M6E is really the fullest featured UHF device that we provide. It has 4 separate camera ports and is the most feature-rich of the UHF devices we have. And then lastly but not leastly is the Nova, which is actually has a nice little niche in that it's got a lot of power and is very efficient. So it's got a nice little mix of power efficiency as well as antenna output power. And I do talk about the antenna ports, but keep in mind with any of these devices, you can apply multiplexers to them. So you can duplicate the antenna ports 4 or 8 times if needed, and we do supply the multiplexers. The other thing of note that I didn't go over is that the HF devices all have onboard antennas, and can be used separately or on their own, but also have the capability to have an external antenna added to them if geometry dictates. And we'll talk about some applications later on that use that. There we go. So embedded RFID enables you to provide anti-counterfeiting. It ensures genuine solutions are used in lab procedures, guarantees medical devices are used, and test administered as they're supposed to be, based on the requirements by the device manufacturer. You can definitely match correct medication, blood, and treatments in really optimizing the patient experience and customer care. Inventory. You can do this in real time. You can maintain your supply. You can verify what reagents are in the device at any one time, what have been used, how many times they have been used. So it allows you to make sure that you're never in need of reagents or always in the process of ordering them when you need to. And then track. Part of this means that adherence to guidelines for workflow process and just making sure that the products are used as the device manufacturer specifies them to be used, which includes verification of lot IDs, expiration dates, directions and configurations for the device, so that the RFID tags can actually provide configuration for the particular reagents or cartridges that are used in the device and help in the setup. And then in a couple of these slides, there are links provided. So after we do after we distribute the slide deck, you can visit the link for a little more in-depth info on the particular topics. So as far as our agenda goes, we've gone over the brief intro to JADAK, the RFID technologies, as well as some of the specific products that JADAK has and some of our capabilities. We've also addressed the questions of why would we use RFID in general, and also relative to some of the other technologies that are available for your tracking and authentication needs. So now let's talk about how does RFID meet the needs and requirements in a clinical diagnostic application? So RFID does have read and write capabilities. This separates it from barcoding. Read-write allows for information such as number of uses, identification of those who access it, date, code, and also date of use comparisons. The RFID provides close read range for discrimination. So similar to the barcode application where line of sight allows you that discrimination, you know exactly what you're reading. You can use the close read range for discrimination. And then you have longer range applications for inventory, warehousing, things like that if need be. RFID does not require line of sight, as we talked about. It provides authentication, and tags can be hidden under labels or even molded into plastics so that somebody trying to counterfeit this is not even aware that it's there. And tags can be encrypted or password protected by the host for safety and security. let's see. Okay, what problems are we trying to solve with RFID in reagent authentication applications? Lost revenue, for one. Only sanctioned disposables are used, and it stops counterfeiting. A lot of device manufacturers obviously make some money on the devices that they build, but they really build those devices to make sure that they sell their reagents or their processing cartridges. So you don't want to lose revenue with that razor blade model. Brand integrity neutralizes negative association and market degradation due to knockoff disposables. If there's a mistake, they won't blame the reagent used, they'll blame the name on the device. It ensures the product and patient safety. Devices operated, configured and used the way they were intended to for safety and security. And then really this prevents legal liability. You don't want to talk about it, but it eliminates lesser quality substitutes being used, prevents use of expired or unapproved items, really decreases the chance of human error, whether it's via knockoff reagents or somebody just using the reagent or the device improperly. Then it verifies expiration dates as well. Verification of used by dates and only allows consumption of reagents if those dates are not expired. So back to the agenda. We've gone over some how, and now you know how these RFID devices can be used to help meet the needs of the application, as well as some of the problems they solve. So now let's get into specific examples. So in this particular application, the M2 RFID reader was used. It had some custom firmware that we created at JADAK that enables the encrypted data to be passed through the M2 between the tag and the host. In this case, the supplier of the device itself wanted to do the encryption and then use the pass-through capabilities of the M2 to send this encrypted data directly to the tag and communicate with the tag. So this ensured that the reagents that were used were from the customer, needed no interaction from the user, just place the bottle in and go, and then ultimately that the encryption allows for anti-counterfeiting protection. Of the devices that we offer at JADAK, the M2 is unique among the interrogators because it can both do the 15693 tags as well as the NFC 14443 tags. Most interrogators can read the UID from both of these types of tags, but actually accessing and using many of the features associated with these tags is unique to the particular format, and the M2, being the most full-featured HF interrogator we have, can do both. The pass-through command allows the host to perform authentication and handshaking between the host and the tag, which in this case resulted in AES 128-bit encryption key being passed to the tag and stored on the tag. Another aspect of this application is that both the internal antenna on the M2 was used as well as external antennas. All the JADAK HF modules, as I mentioned, have onboard antennas, but depending on geometry or space constraints, sometimes it's very useful to have that external antenna. So this really allowed this device to be scalable. There were actually two device models, one that had one reagent bottle and one that had three. And because of the scalability of the M2 and how we designed this, they could use the same parts in both of them and so have economies of scale associated with this device when it comes to the M2 and antenna configuration. And then lastly, this is not a webinar on tags, but I did want to throw out some specs just so if you're a little uninitiated, you know, it gives you a feel for what some of the tags can do. This particular application used the iCode DNA tag from NXP, which is one of the bigger suppliers of RFID tags. It is in fact enabled with 128-bit AES encryption. This unit has 2048 bits of user memory that's organized into 64 blocks of 4 bytes each. And this tag's actually spec'd for 50 years of data retention, as well as a write endurance of 100,000 cycles, and has a fast transfer rate of 53 kilobits per second. Excuse me. This is another application using the M2 and encryption, slightly different from the last one. This customer needed to verify that only improved reagents were used in the device. So this application is a little different in that it actually uses the encryption performed by the M2 itself using the readware software. The M2 with Sky Security readware software supports DES, triple DES, as well as AES encryption. In this case, the customer was concerned about counterfeit, basically what the counterfeit reagents could do. Really raised serious safety concerns and also financial concerns. Really it would impede the device's ability to verify and validate the test results. So this, might result in the requirement for a patient to come in multiple times because of a misdiagnosis. And that never looks good for any company. In this particular case, the customer was actually able to use a generic RFID 15693 tag. In this particular tag by itself did not have encryption capability, but they were able to save a few cents on these tags because encryption tags are just slightly bit more expensive than the standard tags. And they had the capability to use encryption with the Sky Security readware security algorithms. So an RFID for, once again, counterfeit reagents in a clinical machine. There's potential negative impacts to the manufacturer's revenue and brand reputation, always. In this particular case, the most important issue to the customer was that the reagent cartridges not be reused and refilled with knockoff reagents, really resulting in potential legal ramification as well as brand reputation. They were informed by a particular country that counterfeiting is going to happen. And reuse of these cartridges would happen, and that ultimately they needed to be able to prevent this. In this particular case, they used the kill feature of the RFID tag to disable the tag after it was used. So most of the RFID tags have the capability to disable themselves or basically disable from a command from the host so that they can never be used again. The cartridges, mechanically in this case, could be duplicated, but that would be pretty obvious. So it was much easier for the counterfeiters to gather up the used cartridges and get those disposed cartridges and refill them. So with the kill tag feature enabled, the knockoff cartridges definitely wouldn't be recognized by the device and prevented the knockoff reagents potentially from being used improperly in the device. So single source example. This application uses RFID for inventory, which is a little bit different from some of the other examples we talked about. The customer needed to verify what reagents currently were inside the device. The space where these reagents were contained was approximately, just think about it, about 2 feet cubed. So really, when we're talking about feet, that really dictates a UHF interrogator as opposed to an HF interrogator. And for this, excuse me, JADAK provided one-stop shopping which included interrogator selection, mechanical bracketing, antennas, and specialized software for talking with the host, as well as tag selection. which would work in the presence of liquids. I'm not sure I mentioned it before, but between the two technologies, HF is much more tolerant of liquids, but with the E fields used by UHF, metals and liquids particularly can attenuate the signal. So it's definitely something you need to consider in any of your designs, but there are tags that are made to be used in the presence of liquids, or for that matter, even on metals. So in this particular case, we specified a tag that was good for being mounted on a liquid bottle in this case. And if you think about it, many device manufacturers don't have RFID experience in-house, and you want, but you still want a complete solution. So it can be beneficial for somebody like JADAK to completely take the development of the RFID section of the product off their plate. And it kind of highlights JADAK's mantra in that we can do as little or as much as you need us to do. So if you need individual components and your guys are going to handle the integration and connection, that's fine. If you need a complete solution, we can also provide that. So, RFID for cross-platform compliance. So this was a sterilizer company that basically they had multiple designs for one common product, and then they had multiple formulations for these various designs. And what they wanted to do was have a kit that included not only the RFID, but also a reader and a small display, as well as a small processor. So the kit could be used in up to 8 different product lines, and each one of these product lines, although there were common formulations across the product lines, there were also unique formulations that needed to be used with specific products. So in this case, the RFID reader is used to verify the consumables being used in the machine, and this is to ensure that the performance is correct and also to prevent the use of expired formulas and making sure that the formula is appropriate for the device that is actually inserted in. This particular case, the customer was less worried about counterfeiting and really more worried about their own variety of formulas being used properly in their various devices. And also, ultimately, that the product had not expired. This made sure that the formulas were properly configured and used in the specific applications or specific devices, and that misuse of these did not happen. So this is another reagent tracking and disposable verification project. In this case, the customer was doing a product refresh and wanted to take advantage of some of the features that RFID provided. They already had a barcode reader in there, and they wanted to limit the impact of making any changes in the auto ID technology. So JADAK created a prototype for a proof of concept that was a drop-in replacement using the same cable connections. We did software on the device that mimicked the barcode reader protocols, and also a bracket so that the samples, when they were placed in the device, were placed in the same way, thus eliminating reuse and training. So they're going to use the device exactly the same way they used it before. And this minimized the impact of changes that needed to be made on the host side. The application uses the kill tag function to eliminate refill of any of the custom bottles and cartridges used, and after the minimum number of draws out of these cartridges were reached. This did not use encryption, but did use the password protection for the read of the tag. So it just kind of shows there's different ways and methods of security that are available with the RFID devices, tags, and systems that you use. So this is an NFC application. This used the Gemini reader that we highlighted earlier, which is an NFC interrogator. They had a they had selected a tag. So this company was actually much more proactive. They wanted to use a Gemini. They had already used a tag. They looked at the specs on the tag. They verified the features that were available on the tag. And basically, they came to us and said, we want to use this functionality of the tag, and the Gemini software itself at that time did not have the ability to do that particular functionality. But what we did as a company, we modified the Gemini firmware to take full advantage of the features of the selected, the tag selected by the customer. So this kind of brings up the point of why are there so many tag manufacturers? There are, really highlights that there's so many tag manufacturers because that's how they differentiate themselves, is by taking the basic 15693 specs and the 14443 specs for the NFC devices. They all do those basic requirements, but then they try to differentiate themselves above and beyond that with other features, which would include encryption capability, the ability, for instance, to read over multiple memory blocks and limit the number of read cycles that you need to do. Differing password capabilities, whether it's per tag or per individual block. So not all 15693 or 14443 readers can take advantage of all of these tag features. Most of them can read the UID. So if you're just interested in unique identification, that's probably fine to switch between readers. But if you really want to take advantage of the full features of the tag, you need a reader that is specifically designed for the requirements of that tag, whether it be standard HF or NFC. But really, the readers, if you want to use a tag that has a feature that isn't enabled in one of the JADAK readers, please talk to us and we'll be more than willing to enable that feature for you. So this brings us to the end. Just want to highlight that we do have the capabilities to do hardware, software, mechanical engineering to design what you need. We can offer or recommend peripheral elements, whether those are displays, processors, printers, anything to really support the readers, which includes antennas and multiplexers as well. We can help you select tags and support advanced tag features, such as the cryptographic security for both HF and UHF devices, and also support the UHF RFID sensor tags. And ultimately, we strive to provide exceptional customer service during and after the development. Our goal is really to have JADAK engineering really be part of your engineering team and as accessible and responsive as we can be, and in some cases, sometimes even more so responsive in your engineering. So that concludes the talk. Are there any questions?
Hi, Rob. So we did have, well, first off, can you hear me?
Yes, I can. Thank you.
Yep. We did have a few questions come in, so bear with me here. There was a bunch. One of the questions is, can you talk a little about tag costs?
Yeah, it's a good point. There, obviously we talked about the two different technologies of both HF and UHF. Just because of the manufacturer of HF tags, if you think about it, it's a loop or a series of loops, and ultimately that conductor is going to pass underneath or over top of the loop to connect back to the IC on the tag. And because of that, it's just slightly more complicated to manufacture an HF tag, and consequently, the HF tags are a little bit more expensive than the UHF tags. On the flip side, HF tags tend to have larger data capacity than an HF tag. So there's pluses and minuses to both, but typically in the quantities that we're talking about for a lot of these consumables, and by that I mean hundreds of thousands to millions of tags, you're talking for HF tags, depending on the capability, anywhere from about 15 cents up to about 30 cents. And UHF tags can be a little cheaper. You can see some as low as 5 cents, but you're typically talking somewhere in the 5 to 15 cent range for those tags in very high quantities.
Okay, thank you. Here's another question is, in the presentation you talk mostly about HF RFID. Why don't you see more applications using UHF technology in this space?
That's a good question, and actually you did see the one application using UHF, and you also saw that it's really more where UHF would shine in a inventory type application, where you're attempting to read, I think in that case, was 6 or 8 different reagents within that space. One of the big advantages of the HF technology is in the discrimination. The short read range, where you think might be a disadvantage, actually comes out to be a positive when you're talking about wanting to make sure you're reading exactly the tag that you want to read. So that's why it's used a lot in the clinical space. And then the other reason is because of the memory capability of the tags. Having that extra chunk of memory to be able to include things like expiration dates, lot numbers, what are we talking about, configuration information for the device to actually help set up based on what kind of reagent or cartridge is being used in the system. And not that you can't do some of those things with UHF, but you're really just typically in a UHF application, you're looking for an ID number or a part number or something like that. And then the other thing to consider too with UHF, even though you can go in some cases, 30, 50 feet and get good reads at that distance, you really need to be aware of the environment that you're using it in. Because metals do play an important role in the attenuation of the signal, as well as liquids. So it's really, once again, kind of getting back to using the right tool for the right application. And we can definitely help you with all those design and integration questions that you might have.
Very well. Now we have 2 questions that are pretty technical, so hopefully I say these right. One of them is, we are interested in knowing whether the country-specific registration or notification is required to be able to place on the market medical devices that contain RFID tags. Do we have to declare use of RFID frequency in some countries?
Not necessarily of the tags themselves, but you definitely do need to be aware of the RFID interrogators, the power output, whether or not they pass the regulations for that country. In the case of the HF devices, it is called modularly certified. And not all of the HF readers that JADAK provides are modularly certified, but if that is important to you, we can definitely guide you to the appropriate solutions for that. And the key about modular certification is that it is at a component level. So we did talk about the HF readers having onboard antennas. That modular certification is with that onboard antenna. If your geometry dictates an external antenna, there are some regulatory requirements that you're going to have to pass because you have modified the device that was certified as is. Yeah, I think I took care of that one. But yeah, they are specific country regulations. Oh, and then the other thing to consider too, especially in Europe, they recently passed and required the RED directive, which is Radiated Emissions Directive. So any of the devices need to be RED. Any devices sold to Europe need to be RED certified. And once again, I would say 90% of the devices that we have at JADAK have passed RED certification and are capable to be sold in Europe, but that's something to consider again.
Got it. Thank you. Another technical question is, do products containing RFID tags need to wear specific marks that inform the user that an RFID tag is included in their product? The question is related to waste management. Do products containing an RFID tag require a specific waste management?
That's actually a very good question, and I can answer that in part. And we will have to get back to you on the specifics about the waste management, though. The RFID tags themselves do not have to be marked. And like I had mentioned before, in some cases, the RFID tags are actually embedded into the plastics. So unless you're privy to that information, you're not even going to know that an RFID tag is in there. We do have customers that specifically print out labels that identify a label or a specific part of a label or a device. Basically, that label identifies that is where the RFID tag is. So you typically need that in the case of a hand reader, where the user needs to know where to put the hand reader. But yeah, as far as the waste management, I do not know of any of specific requirements for that, but I would like to dig into that a little bit more and get back to you on that.
Cool, very well. Another question is, are all of these products available to reseller partners?
Yes, I think clearly. Obviously, that's more of a business decision, but yeah, we do have resellers for these products, but we would have to get the proper paperwork in place, but we could do that.
Cool. Another question is, what are some other examples of how RFID can be used in clinical diagnostic applications?
We covered the basics here. Most of the clinical devices obviously have to do with protecting and verifying the reagents or the cartridges, which are really the razor and razor blade model for most of these companies, where they want to secure the continuous cash flow from the use of their specific reagents. But there is one that comes to mind that's a little different. It is a medical device, but it's a handheld device, and this is a little unique in that they do have a disposable associated with this device, and they expect their numbers are on the order of not just hundreds of thousands of disposables to millions, but they're talking millions to tens of millions for this device. If you think about a handheld, for a couple reasons, you would think HF. One would be the potential close proximity. The other is for UHF devices, there's something called SAR, or specific absorption radiation, that you do need to be aware of when you're using a UHF device. In many instances, that dictates, depending on the output power of the antenna, that the user be separated from the antenna by up to 20 centimeters. But in this particular case, for a combination of regions, instead of going HF, we went UHF. Reason being the total number of tags, so even a 5-cent difference between a UHF tag and an HF tag could be a big dollar number when you're talking tens of millions of these disposables. And then the other way we kind of got around the SAR aspect is because of the close proximity. We could detune this device to such a level that the radiator was not even technically classified as an antenna, and thus we could use it at very, very short ranges and then not have to worry about the human aspect and human certifications of the specific absorption radiation, or SAR, associated with that.
Cool, thank you. And the last question, I believe I can answer it, and that is, will this presentation be available for online review? And the answer to that is yes. As soon as we wrap up this presentation, we're going to work on sending the recording out to everybody who registered. So even if you did not attend the webinar, you still get a recording for it, for just registering. And also, it will be on our website. So give us about a week, and we should have that over to you. Is there any other questions? Okay.
Oops, hang on. There you go.
There we go. And up on the screen now, we just have our upcoming events. We'll be at the Medica Trade Show this year from November 13th through the 16th. In April, we'll be at RFID Journal Live in Orlando. And in the summer, we'll be at the AACC trade show in Chicago. We're also currently working on another RFID and IVD applications webinar, and that's the date is still to be determined, but that will be in December. At this time, I'd like to thank all of our attendees for joining the webinar today, and a special thanks to our presenter, Rob, for his presentation. As I mentioned before, a recording of this session will be automatically emailed to all those who registered for the event within the next week. If any of our attendees have any further questions on RFID or any of our other technologies, we invite you to visit our website, jadaktech.com, or schedule a tech day with us by emailing us at techday@jadaktech.com. Thank you again, and have a great day.